It begins as a perfect day, warm, sunny, some haze and humidity, but cloudless and soft. Then as the sun rises high in the sky, it heats the air at the ground and new forces go to work. At first, just invisible bubbles of warm, moist air rising and forming short-lived cumulus clouds. But then more clouds, taller, building and accumulating and growing darker and darker till suddenly, and then just as suddenly, the quiet and calm. The thunderstorm is gone. The sudden violence of thunderstorms is something that folks here in Oklahoma have learned to live with. They have thunderstorms about 60 days out of the year. But believe it or not, Florida has more thunderstorms than Oklahoma. Actually, thunderstorms can occur just about any place at just about any time. An average of 45,000 thunderstorms a day form on the planet Earth, and in each one may lurk energies 10 times that in the bomb that destroyed Nagasaki. Thunderstorms need a number of elements to develop. Included are moisture, uplift, and strong upper-level winds. Uplift is created when the sun heats the Earth's surface, when wind hits a mountainside, or when cold and warm air masses collide. When the surface air rises, it cools, so moisture in the air condenses and forms clouds. This is the cumulus stage. At this stage, the storm is made entirely of updrafts. If there is a strong wind aloft, like a jet stream above the cumulus cloud, air is removed from the cloud at the top, and more warm, moist air is drawn in at lower levels, adding energy to the storm. Finally, the water droplets and ice crystals that make up the clouds become too massive and heavy for the updraft to support. They begin to fall. As they fall, they drag the air down with them, creating a downdraft. Now, several updrafts and downdrafts can exist in a single thunderstorm. At this point, the thunderstorm is mature. Heavy rains fall in the downdraft. Strong winds fan out at the bottom of the storm in what's called a gust front. There's lightning, maybe hail, and sometimes, but not often, the thunderstorm's most frightening product, tornadoes. Finally, the updraft weakens. The downdraft takes over, and the storm collapses. This thunderstorm's life is over. But meanwhile, this storm's gust front may have aided in the development of more thunderstorms. The cold downdraft undercuts warm, moist surface air, providing new uplift for another storm. When this kind of chain reaction occurs, the developing storms merge to form clusters or lines. As this series of satellite photos show, those lines of thunderstorms can be hundreds of miles long and race across a landscape at up to 60 miles an hour.
One other way that we get organization, and we get it in the spring and summer months of the year, is we get complexes of mini thunderstorms, maybe 100 or more, that all form together into this thing called a mesoscale convective complex. And it grows so large that it has a mind of its own. It's hard to forecast, and it changes the weather, for instance, for the next day. It's so big and has such long-lasting effects that once created, it may last 2 or 3 days and affect several states, maybe go all the way from the central part of the country to the East Coast.
It's that kind of thunderstorm that causes serious complications. We'll look at those complications in Part 2. For the Weather Channel, I'm Dennis Smith.